cover carrageenan to form a wet thixotropic or shear thin gel. And then after that, you've got your xanthan carrageenan, which bridge with foie and locus beta to increase your viscous behaviour.
Hello?
Hi Isabel, it's Ricky. I was remembering of the food talk episodes and I realized that we haven't quantified the microstructures and the rheology of our custard.
Oh, yeah, that's right. But today the lab's closed.
Oh, so like can we use our household equipments to do that?
Yeah, I have a few tests. Do you mind if I come over to your house?
Oh, that'd be absolutely great. I'd be obliged. See you then. Welcome back everyone. So Isabel, can you just tell me that why I need to apply so much force to just take it out of the container?
The custard has a yield stress from the polymers of starch and gums. And I remember Jamie used to measure this back in the lab, and I'm sure he has some solutions.
Oh. Hello?
Hi, Jamie, it's Isabel.
Hi.
I'm doing a couple of tests at home to measure the yield stress. Do you have anything I can do?
Well, I'd recommend getting you 2 syringes,
Yeah?
a bunch of coins, a
Yeah.
cup, and also a water bottle with the bottom cut off and then 2 holes cut in the top.
A water bottle with 2 holes and it's cut off. Yes!
So, we need some custard fresh out of the fridge at 4 degrees, which we suck into the syringe and put it upright like this. Then we put a stack of 20-cent coins on top of the syringe and measure the time for the custard to flow from the 15 ml mark to the 5 ml mark. In this experiment we used 5 different weights, which are 20 coins, 23, 25, 27 and 29. But first we need a correction factor, since to flow the custard in the syringe has to overcome some air pressure and more friction. As it turns out, an empty syringe needs 11 coins to get moving. Now, one 20-cent coin weighs 11.31 grams. The force we exerted to squeeze out the custard is equal to the mass times gravity, and the pressure is the force per area. So we get a plot of pressure against flow rate, and with the thick custard you can see that when it's cold, like fresh from the fridge, you need more pressure to make it flow, compared to doing so at room temperature or thawing custard. It's because at higher temperatures, all particles have higher kinetic energy, and the pouring custard, as the name indicates, is made to flow more easily. In the range of pressures that we've worked with, all the plots are quite linear. The intercept in the y-axis is supposed to be the yield stress, the stress in which the fluid needs before it starts flowing.
So why is the yield stress so high here?
It's probably because it's not linear in the zero shear rate region. It's much more steep, meaning it's characteristic of the yield stress fluid. We can measure the yield stress using the slump test.
We use a conical shaped cup to make sure that the structure won't topple off when we remove it slowly. So we assume that the flow is purely extensional. The initial height of the coffee cup is 112 millimeters. The upper radius is 52 millimeters and the lower radius is 68 millimeters. The final shape of the custard after the slump test is noted down to be 27 millimeters. So plugging these values into the equations, that is S dash is equal to h naught minus h upon h naught, which is the relative change in the dimension, we find the sigma, which is 1 minus s dash upon square root of 3, and plugging all these in the yield stress equation, which is equal to sigma into density into gravity into the height, we find out that the yield stress is 168 pascals. Okay, so let me get it straight. I want to know the viscosity of custard. I mean, it's thick, but then once I put it in my mouth, it's creamy. It thins. Why?
I know the perfect person to answer this question.
Yeah, hello?
You can do the same test with the syringe, but this time you compare it with a Newtonian fluid with known viscosity like water. Since you keep the pressure difference constant, the Hagen-Poiseuille equation can be simplified to calculate the viscosity. Custard is shear thinning, meaning the viscosity would be lower at higher shear rate than shear stress. What you obtain from the experiment is only an average viscosity because of this, but you'll see that the custard is generally 40 to 100 times more viscous than water, mainly due to the starch networks and carrageenan bridge.
It's been an interesting day, isn't it, Isabel?
Yeah, we learnt how to demonstrate the yield stress and shear thinning properties of custard using experiments you can do at home.
So So I believe this is the end of the series. I, Ricky, on behalf of Food Talk, and Isabel on behalf of Dairy Farmers, bid you goodbye. See you soon.
Cut.